Hello, and thank you for joining us this evening. I'm Helen Soslowski. I'm the events director for Oblong Books in New York's Hudson Valley. Before I introduce our guest this evening, we will be doing a Q&A at the end of the discussion. So if you've got any questions that you'd like to ask Sara, our guest, and James Nestor, please leave them in the Q&A or the chat. Q&A is at the bottom of your screen, and so is the chat. And if you click on the little chat module, it'll appear on the right-hand side of your screen. We're delighted this evening to be hosting author Sara Mednick for the launch of her new book, The Power of the Downstate, which is available in our stores and online through oblongbooks.com. I'll post the links in the chat for those of you who'd like to purchase a copy a little later. In the book, Dr. Mednick creates a comprehensive picture of the upstate, downstate rhythms that orchestrate all of our body's vital systems and offers practical, evidence-based insight into how we can all enable those systems to work together in better harmony. Dr. Mednick is Professor of Psychology at the University of California, Irvine, where she directs the Sleep and Cognition Lab. Her first book, Take a Nap, Change Your Life, put forth the scientific basis for napping to improve productivity. We thank you for that, Sara. Cognition,
the first downstate.
and health. Yes, it gave us all permission. Dr. Mednick's lab investigates the mind and body mechanisms that support performance improvement. Her work has been continuously federally funded with grants from the National Institute of Health, the National Science Foundation, the Department of Defense Office of Naval Research, and the Defense Advanced Research Projects Agency, which is a United States Department of Defense agency. And her work has appeared in the New York Times, the New Yorker, the Los Angeles Times, the Washington Post, on the BBC, and has been featured on Good Morning America. And congratulations on Publication Day today, Sara.
Thank you. Thank you so much. It sounds really good when you say it, Helen, because you have such a beautiful accent.
Well, it is. Moderating the conversation for us this evening, we are delighted to welcome author and journalist James Nestor. James is the author of Breath, The New Science of a Lost Art, and has written for Outside Magazine, The Atlantic, National Public Radio, the New York Times, Scientific American, Dwell Magazine, the San Francisco Chronicle, and more. Welcome to you both. It's a delight to have you with us. And James, I'm going to hand over to you.
Thanks so much for those lovely intros there. Let's start right off, Sara. Can I call you Sara or Doctor?
Oh, please. Can I call you James?
Which do you prefer?
Okay. I prefer, all my students call me Sara.
Okay, Doc.
Not that you're my student, but yeah.
Well, I'm going to learn a lot this hour, so thank you for prepping me for that. So let's just start off. What's a downstate? What's an upstate?
Great. Well, I just want to actually start by thanking you for being here, thanking Oblong for hosting this event. I went to Bard College and graduated in 1994, and I still, remember Oblong from years back, and it's just great to now have my book and have this event with Oblong. So I really appreciate it, and just thank you to everybody, my family, and Hachette, and my publicist, Angela Baguetta, and my agent, Laura Nolan. Thank you all so much for making this possible. All right, so let's launch in. So what is the upstate? What is the downstate? I think that it's a good idea to kind of step back and think about where the idea came from. So when I was doing my first book, Take a Nap, Change Your Life, I was looking at the nap, and because that's one of my dissertation was about, and how the nap can be this great middle of the day pause where not only can you just relax, but it's also the sleep that you got could improve your memory and perception and creativity and all sorts of things. And then we started doing, I got a lab and started doing more and more research, and found that one of the most important parts of sleep was something called a slow wave. And the slow wave is a rhythmic signal. That's the slowest rhythm that your brain can get into in the deepest part of sleep. And this slow wave was responsible for many of the most important restorative systems or restorative effects of sleep, including increasing memory and increasing growth hormone, increasing the lymphatic system, which is the one that kind of washes your brain on a nightly basis of all the toxins that can build up. And if they don't get washed out, they can form the plaques of dementia and Alzheimer's. So clearly this slow wave was really important. And the slow wave is a rhythm, meaning it goes up and down. And the first half of it is called an upstate, and the second half is called a downstate. And that's what sleep science coined, these terms of upstates and downstates. And when I started working on that, what we discovered, and me and other people, other labs, is that a lot of important neural communication happens in the upstate. That's when you have your most active period of the brain. And then your brain goes into this downstate where all the neurons basically are silenced for just this little half second. So you have half second of activity and half second of silence and quiet and just, peace and rest. And it turns out that those are both really important, right? The first one is the active stage, and the second one is the repose stage. And that system seemed to be a really compelling rhythm that I was interested in studying. And then we moved into looking at the autonomic nervous system, because I also knew that the autonomic nervous system, which has two sides, it has the sympathetic, which is the flight or fight response, that's the stress response, right? And it has the parasympathetic, which is the rest and digest, and it's the relaxation response. And I started saying, oh, well, that, and you get these two sort of twin systems that the second that your heart starts beating really fast because you're excited or you're stressed or you're nervous because of the sympathetic system getting excited, the parasympathetic comes right in and tries to calm your heart down and doesn't, wants you to get restored because it's very stressful to have your heart racing super fast. So I started seeing that upstate, downstate cycle in your autonomic nervous system too, that the upstate was a sympathetic and the downstate was a parasympathetic. Then that started, growing into this idea that scaled, right? That actually nature might have set up this system where we are rhythmic because it provides prioritized space for activity, which is, energy depleting, which requires a lot of glucose, and it requires a lot of all your mental processes focusing and your muscles really working really hard. And that takes a lot of energy and it needs to be replenished. And so nature has provided this state of an upstate where you can be active and a downstate where you can be replenished. So the power of the downstate, right? This beautiful book that I'm so excited about. This is basically looking at all of these systems of downstate recovery that we have and that we need. And how we can, that there are some universal systems that are outside of our control, that are upstates and downstates, such as, circadian rhythm set by the sun and the moon, right? We have active upstate during the day when the sun is out, and then the whole world goes into a downstate when the moon is out. And so those are things that we obviously can't control, but there's a lot of things that we can control in terms of choosing behaviors that optimize when we're doing active things, right? That because if we can optimize that, then we can always be active when we have all the glucose we need, when we have all the energy we need, when we have all the nutrients we need. And then we can be in a downstate when those downstates naturally are occurring. So that was the idea.
So if I got this right, the upstate is when we are active and processing and need energy, and the downstate is the recovery mode.
Yeah.
Is that something like that?
That's exactly right. Yeah.
Oh, okay. So, something that I talk to a lot of people, and they know the parasympathetic and the sympathetic system, and they know that most of us are in this upstate phase way too long, and it eventually wears us down. It's like driving a car 24 hours a day, without doing any maintenance. How specifically does modern life keep us in this agitated upstate phase for so long?
Yeah, I mean, man, that's it's such a dilemma right now, right? Is how do we are in an upstate in we're in way too long of an upstate in every aspect of our lives. The book talks, in the book I talk about the autonomic nervous system, sleep and circadian rhythm, exercise and eating. And in all of these cases, let's just talk about eating, right? Eating is a stress, you actually create a stress response when you eat, and you have an inflammatory response. The kinds of foods that we eat on a regular basis now keep our bodies in high upstate stress response for too long. This kind of fast food, ultra processed food, stuff that is actually really easy to immediately get energy from and immediately get sugar from. And then we eat that all day long, and then we also eat all night long, right? So that also, we don't even give our metabolism the break that it needs, which is, why I think we now see the really benefits of all this time restricted eating, all the fasting type of rituals, right, that people are seeing being so healthy, is because it's just trying to cut down on the window of upstate eating so that we can have a nice long downstate for our metabolism. But, that's just the eating realm. But you can see, I mean, God, who isn't on social media too often, in front of a screen too much, getting enraged by what you see on the news. And a lot of the time, the time that we actually are looking at those things are when we're supposed to be powering down, right? We work like crazy all day, and then we finally can relax. And it's the time when we should really be just, getting away from bright light, getting into relaxation mode. And that's when we get to bed, turn on the phone, and start looking at, whatever horror is going on in the world, which keeps us also in this emotional upstate.
Let's just talk about the eating part of that. I thought that was really interesting because a lot of us assume that calories are calories. You take in a certain amount of calories throughout the day, and that is what you need for your energy expenditure. If you eat too many calories, then you're going to gain weight. If you eat too few, then you're going to lose weight. But that's really not the case, because it depends on when you eat those calories. And I thought that this was fascinating. Just the time of day that you choose to eat food affects whether or not you're going to gain weight or lose weight. Maybe you could talk a little more about that.
Yeah. So think about the circadian rhythm, which is this 24-hour rhythm that's set by the sun, right? So we have the second your eyes see the blue light of dawn, or whatever time you're waking up, you start the circadian rhythm. And what that does is it heats up your body and it gets it ready for energy expenditure. So your metabolism is at its height during the day. The amount of the amount of insulin that your body is creating, and insulin is the stuff that takes your food and turns it into energy, right? And brings the energy into your cells. It's at its height during the day. And your metabolism of glucose is at its height. And at the same time, and so what that means is that this is when you should be eating. And the research by Sachin Panda, looking at his time-restricted eating research, showed that when an animal, but also humans, but an animal eats in that upstate window where it's primed and ready for eating, and it can basically eat whatever it wants. And of course, you should eat healthy, but it's pretty interesting that when your metabolism is at its height, it can tolerate high levels of different types of calories. But right around 3 o'clock, right, everything starts to go into downstate mode naturally. Your insulin drops, your glucose metabolism, everything drops, basically, your metabolism drops. And what that does is, if you don't have enough insulin, you're leaving more of that glucose in your bloodstream that can be turned into fat. So there's studies that look at when people front load their calories to the upstate day versus allow them to eat sort of more towards the evening. And you see really big changes in weight loss, in HDL, the good cholesterol, in symptoms of metabolic disorder. So that front loading of the calories during a time when you're naturally primed to be able to tolerate food and really process food can mean a big difference, which is why I think, and I think that's something that we don't hear enough about, is like the why. You know, we're told don't eat at night, but then of course, like that's my weakness is chocolate, right? I just like 10 p.m. chocolate, just so perfect, 9 p.m. maybe. And it's something I have to fight because, and I have to fight it by knowing that this is probably the worst thing I could be doing, right? Because it's sending a signal to my system to wake up the sympathetic nervous system, right? Which in the book I call rev, because it revs you up and rev you up at a time when the parasympathetic system, this what I call restore in the book, because it's the most restorative time, that is the height of when you should be going into restore function, because when your restore activity is happening at the same time as your first deep sleep time, you get the biggest bang for your buck, basically restorative wise. But when you eat later into the evening, not only are you sort of waking the bear in terms of your metabolism, but also you're changing your sleep pattern. So you can actually delay your melatonin, which is a sleep hormone that signals you to go, it's time for bed. You can delay your melatonin by hours, right, by eating late. So all of these systems, I think, the thing that we need to think about is that we are not these siloed systems, right, where sleep is its own thing and eating is its own thing and exercise is over there and autonomic nervous system is totally separate. Everything is interactive, and what you do in terms of your eating is going to affect your sleep. What you do in terms of your exercise is going to affect your autonomic nervous system, and those two things are all going to affect your sleep.
I was talking to Dr. Stephen Gundry, and he was mentioning that they did this study where they had two groups of people, and one group was able to eat for 12 hours throughout the day. The other group was only able to eat in a window of 8 hours. Same exact food, same amount of calories. And that group that was eating in the 8-hour window lost weight, they gained more muscle, they were healthier across the board. Everything you just said, it's just interesting because I grew up learning that it was 100% about calories in, calories out, and we're learning now, the science is clearly showing us that it is so much more nuanced than that. So let's talk now, we talked about eating, let's talk a little bit about light. And I thought this was really interesting in your book. You were mentioning that so many of the frequencies of light that we're exposed to now just weren't around 120 years ago, 130 years ago, and how we're really this test case for how animals can tolerate artificial light. And if the mass amount of the laundry list of maladies is showing us anything, it's light exposure is causing a lot of problems for a lot of people. So I know you mentioned a bit about blue light before, but I'd like to go into that a little more. Specifically, what are the mechanisms through which blue light affects us, and how specifically does it affect us throughout the night and day?
Yeah, great. So, one thing just to kind of clarify, or just as sort of a foundation idea, is that every cell in our body is a little clock. And we can imagine that all of these cells are, maybe instruments in an orchestra, and they can all kind of have their own rhythm and play their own song, but they need a conductor to put a downbeat and just start the show and be like, okay, so this is beat one, and then it can go from there, and all of the cells can have the same rhythm once that downbeat happens. Well, light is the downbeat for your body's systems, all of the different cells, and particularly blue light. So the way that works is that we have these 3 different types of cells in our retina. 2 of them are used for vision, and 1 of them is used to just detect blue light. It's like a blue light rooster, basically. And it just, when there's blue light, because blue light is very strong in the morning, and then the natural light goes from blue into reds and oranges across into the sunsets. You have blues and no more blues and all reds and oranges. And so this cell is sending information into your brain, these circadian centers that are basically programming the rest of all your cells in your body. It's saying, okay, downbeat, this is the morning, boom, right? And so that is this super important signal that when you stay indoors, you don't get that signal, right? So there's a lot of people who are spending way too much time indoors during the day. So that's the first problem. And then across the day, this is what we're doing. We're sitting in front of computers. And by the end of the day, what we should be doing is seeing this transition from blue to red orange, right? Which is the natural system that's gone on for trillions of nights. Instead, a lot of people are, if they're working out in a gym with electrical light, and a lot of these LEDs that are actually energy saving, so nothing bad with LEDs, and it's a good thing. But the problem is a lot of them are programmed to actually emit blue light frequency at their peak. So at their peak, they're literally going against your natural circadian rhythm. And so when you're exposing yourself to that blue light at night, and so if you don't get that on signal, that downbeat in the morning, and then you don't get exposure at night to the red, to the lack of blue light, and you're actually getting exposure to blue light, these systems that are the rhythms of our life, right? Like high metabolism in the day, the upstate, right? Or all the energy and glucose you need for thinking, right? Or for exercise, all of these things that require energy. You need that blue light in the morning to tell you that it's the beginning of the upstate. And then you need that lack of blue light in the evening to tell you it's the beginning of the downstate. So so that's, people who are dealing with light at night, people who work at night, people who watch, on their phone at night, people who arrive in an airport at night and go into a hotel, or all the convenience stores that you can see from Mars, right? So not good.
I'm glad that you mentioned the benefits and the purpose of blue light, because of course once we hear that one thing is bad in a certain context, we consider it's always bad. So here in San Francisco, people are pretty clued into this stuff, and they've got their blue light blocking glasses, and they're wearing them all day from the moment they get up. And I'm just like, oh my God.
They look so cool.
They look terrible. They look so stupid, which is fine when you're home alone at night, which is when you're supposed to be wearing them. So it's, it's not this or that. It's this and that. And it depends on the rhythm, the time of the day. And this is something that I was not aware of this until a couple of years ago. I used to have very bright lights in my house. They weren't LEDs. I'm old school. I had incandescent, but still very bright. When I changed them, I can't tell you what a huge difference it made. And I put on those not so cool glasses at night when I'm reading for a couple hours before bed, but it just makes a huge difference for sleep quality and so much more, because of course it does for everything that you mentioned now and in the book.
And there's research that now in these yellow, these are the yellow lights, they don't look good, but they do improve sleep. And there's studies in, I think it was nurses, where they had them wearing them and their sleep was improved, but also their next day well-being and how alert they felt at work the next day was improved, which I think is really what we want, right? It's not just that we can say we have good sleep, but what's the point, is so that we're more powerful, right? That we can have more energy and think better and do all those good things.
I think especially for shift workers, which you get into a bit in the book as well, like shift workers have this laundry list of chronic diseases. It's almost life-threatening to be a shift worker, and it seems to make a lot of sense in these warehouses, instead of blasting people with fluorescent blue light, to have the lights change throughout the shift, so people are prepared after their shift to go to sleep. But of course this is never going to happen, because it's probably going to cost $200 extra. Companies don't want to pay that. But I think the more we know about this, the more people are empowered to take this information and use it, to enrich their own lives. So
yeah, I mean, if people could just be working with those glasses, that would improve their life. I mean, that you can't always change a lot of people can't just change their jobs, right? But if they could just be given like a $25 pair of glasses, that would be good. That would be
Not even the cool looking ones. You
no,
could just
man. I
have
mean,
the
like
dumb looking ones.
there's so
Yeah.
much that we could do as a society and as corporations and as, you know, the civic governments could be doing to be supporting our downstate, you know, that to be supporting our own internal rhythms. And we could talk about that too.
So your last book was about napping, and there's a lot of sleep in this one as well. But let's talk about, you were talking about these stages of deep sleep, these very downstate, these rich stages of deep sleep, but you don't quite get that with a nap. So can you explain the
Who
difference
says?
between real deep sleep and a 10-minute
Yeah.
nap? Your
10-minute nap. No. You got to
Okay.
sleep for like 60 minutes.
60, a nap for 60 minutes?
Sorry.
That sounds wonderful. If I were European, I'd be all over that. But okay, that was my question. I know this is a little off script, but I have you here and I had to ask, because whenever I nap, it's been like 10 minutes, 15 minutes, and you want that reboot, right? And so is there a benefit to a 15-minute, 20-minute nap?
It's extraordinary how, you know, if I told you, yeah, go to sleep for 10 minutes at night and then wake up, how are you going to feel?
Terrible.
Crap, terrible, right? But you can take a 10-minute nap in the middle of the day and feel like totally rebooted, totally recharged, right? It's astonishing. So why is that? Nobody knows. I can't say anything, you know, I can't say that we know this answer at all. But here's one of the things I think is really critical to think about is the shift that your body and mind experience when you go from waking to sleep is such a dramatic shift in all of your systems. You know, your autonomic system, as we talked about, this rev restore, right? This sympathetic, parasympathetic. During the day, you're in high rev mode. You're revving really high. You're able to, you know, mobilize your resources and be ready for anything. The second you go into sleep, you see this downregulation of the sympathetic rev, and you see this upregulation of parasympathetic, even during early stages of sleep. So it's not just when you go into deep sleep. That's really where you get like the optimal exposure. But even during stage 2 sleep, which is just that, you know, what the power nap is, it's like, you know, 10-20-minute nap is mostly stage 2 sleep. You can see some really high quality parasympathetic activity during that sleep. So, you know, whether it's that, you know, there's also very specific EEG patterns that you see during early stage 2 sleep that are strongly associated with memory consolidation, intelligence, health. So whether, you know, it's probably a combination of all of these different things happening. That's such a massive shift, which is why I think, you know, which is why it's probably a good idea to take these breaks, because you know, whether it's actually with a nap or whether it's something like, you know, doing breath work, which I hope we also start talking about, because I think at the core of it is breathing. And at the core of it is harnessing your parasympathetic restore system using your breath. And when you go to sleep, that happens naturally. Your breathing slows down, your heart rate slows down, everything cools, your body temperature cools. But you can also do that when you're awake. You can do that when you're doing that slow, deep breathing.
Plus, naps just kind of feel good. So why not?
Not for
Why
everybody.
Not? If you can sneak them in, I love them. I just wish I was able to take more of them.
I took a nap just before we got here.
Oh, look at that. And that's why you're so sharp right now, everybody. That's an advertisement for napping. Okay. I didn't, and look at the difference. Okay, there you go. Okay, so let's talk about, we know we can shift these states by sleeping. We can shift them by napping. We can shift them by sleeping a good 8 hours without blue light exposure before we go to sleep. But what can we do for an immediate reset? Sometimes I'm just cranking up in this upstate. I need to turn the frown around, calm myself down. What do you use to do that, to reset and get to that downstate?
Well, I've actually just started doing a really nice 10-minute meditation. And I can tell you just what it is really quickly, just so people can get it, because it's a really, I'm surprised every time I do it. What the hell? Like, how do I feel so much better? It's a 10-minute period, 2-minute sections, 2 minutes. The first 2 minutes is just, kind of closing your eyes, deep breathing the whole time, deep breathing, and then an awareness of the field around you. And then 2 minutes of awareness of your senses. What are you hearing? What are the images on your eyes? How does your skin feel? What are you smelling? Just really tuning in. 2 minutes of your feelings. Feeling, am I, the sad, glad, mad, scared? What are the emotions that are coming up? And just observing, just letting them wash over you, soak in them a little bit. And then go 2 more minutes into your thinking, observing your thoughts. Just, like, what am I going to eat for dinner tonight? What is that sound? Is it like, what am I doing here? And then you close on 2 minutes of just taking a little awareness test of where did I start and how different do I feel now? And it's super powerful, and I'm impressed by this practice. I believe it's a Sufi practice, but I think one of the concepts that I've been thinking about, that comes from early work by Porges, with his polyvagal theory, and then work by Julian Thayer, talking about the importance of vagal activity and the balance between our stress systems and our vagal systems. The vagus nerve is the cranial nerve that kind of turns on the restore system, turns on the parasympathetic system. And at its root is how we breathe. Because in every time you breathe, inhale is a excitatory, it's actually sympathetic arousal system, inhale, and then that speeds up your heart rate. And then when you exhale, it's a parasympathetic restore system, calming your heart rate down. And so in every moment, you have this back and forth between your rev and restore systems. When we start to get stressed, we stop breathing, as you know. We start to have shallow, kind of panicky breath, right? There's this thing, email apnea, right? Where you open up your email and you just stop breathing. And your heart can start to race and you get into a stress mode. In the same way that, in your inhale, you're exciting, and then at the exhale, you're calming down with restore. When you powerfully, intentionally slow your breathing down, you are activating the restore system. Because what you're telling your body is everything's okay. Whatever that panicky, shallow breathing was, that was, or just not even breathing at all, that was making me think that there's something really wrong here. Nothing's wrong. I got this. And it builds up. Not only does it build up your restore system, but it can also build up your frontal cortex, which is the main seat of your executive function and planning and control and working memory and inhibitory function, all these things that are incredibly important for daily life, daily functioning, because that prefrontal cortex is directly connected to your restore system. And when you intentionally slow down your breathing, intentionally slow down even your heart rate, you can intentionally do that as well, you are sending a very strong signal of self-control, of strong inhibitory processes, that you're not just going to be reactive. You're not going to just, jump and react to any stimulus around you. You've got this, right? So it's not only just a benefit for your body, enhancing restore function, it also is really strongly benefiting your cognitive function. And there's a lot of important research that shows that you can even train, it's a bi-directional relationship, meaning that your frontal lobe function and your restore function are in a direct relationship together. And if you train up your frontal lobe function doing brain training games and all different sorts of stuff that affects like your working memory and holding thoughts in your head for a certain amount of time while you're doing something else, tons of games out there that do that, you actually increase restore function. And there's also work that shows that when you do like heart rate variability biofeedback, right, which is just training your breathing and your heart to start aligning, you can increase your executive function, right? Because these two systems are reflecting each other and they're interacting.
Great. I want to mention to everybody, get your questions in right now because we're going to be doing some Q&A here in just a few minutes. So the first one up is the one whose question is going to be asked. So if that doesn't get you in that upstate to get into that chat box, I don't know what will. But now, since I amped everyone out, what specific breathing technique? I like that meditation. I believe it is a Sufi practice. I had heard that from a monk, just this body awareness thing. Then I tried it. I was like, wow, that's amazing, especially for healing too. If you have an injury somewhere, to put all your energy into that one area. And it's amazing what a difference it makes. I had a sprained ankle and used that, and I think it did make a difference. But for the breathing stuff, we've talked a bit about how that can restore things, shift you into a parasympathetic state. But let's talk about a few specific techniques that you use and would like to recommend.
I think you should recommend them. I think this is your
This is your show. This is your show.
I know,
no,
but
no,
you wrote
no.
a book called Breath, and you lead workshops on breathing. I study the science. You are the breath guru.
I think you have that. I would love to be the breath guru and hang out in a robe all day and breathe. That is not what I do at all. So I'm just a filter for the scientists and to extract information of how this stuff works. I do know a few tricks, but I know you do as well because I have read your book. See, there's one benefit of being an author. There aren't many people, but you get these books before they come out, and look at all those notes I have there. And I have highlighted a few sections here in which you talk about specific breathing techniques, and hopefully you can talk about those right now.
So, okay, so for me, understanding how the breath and how our heart rate need to sync up and how that increases restore function was a huge insight. Because, so before I talk about the technique, I just want to give a little bit of the science. We have these rhythms of each system, right? Your respiration has a rhythm of inhales and exhales, inhales and exhales. Your heart rate also has a rhythm where it speeds up and then slows down, speeds up and then slows down. And what it's doing is, trying to gobble up as much of that good oxygen, and as you know, carbon dioxide as well, into the bloodstream while your lungs are full. Well, if you imagine that when we're in our regular life, we're actually breathing very fast. We breathe about 10 to 15 breaths a minute. And that's way faster than our rhythm of our speeding up and slowing down of our heart rate. So one of the most amazing things to watch is when somebody slows their breathing down to match the upstate, the speeding up, which I'm going to call the upstate, and then the downstate is the slowing down, right? When you can synchronize your breathing so that the inhale upstate of your inhalation matches the upstate of your heart rate. And because what happens is then you have these in sync rhythms, right? And you can see the heart rate variability, which is, the basically reflection of your restore function, your parasympathetic function. It goes from being very messy and low when you're breathing out of sync with your heart rhythm to suddenly this super strong, robust system when you sync these things up. Because at the time that you're inhaling and filling your lungs with oxygen is the time when your heart is beating its fastest and gobbling up all the oxygen, and the time of energy conservation when your heart starts to slow down is the exhale, when you don't really, there's no more oxygen to breathe, right? So that to me is a really great insight into why these techniques help. And so the resonant breathing idea, and this is resonant breathing, right? Which is when you bring your respiration and your heart rate into sync with each other, upstates and downstates. The resonant breathing idea is that you breathe basically it's about 6 breaths a minute, which, obviously that a minute is 60 seconds. And so you want to take 6 breaths. So that's 5 seconds on the inhale and 5 seconds on the exhale. Now that is the standard resonant breathing frequency, but there are ways that you can, use a HRV device that can actually approximate your heart, your resonant breathing frequency a little bit more precisely. But I think in general, it doesn't matter. I mean, if you stick with this kind of 6 breaths a minute frequency, that is what all of the research on slow, deep breathing, that is really what is recommended. But of course, then there's, I was talking to a guy, I forgot his name, but he was on the podcast, and he was saying he can bring his breathing down to like, a couple of breaths every 2 minutes or something wild, and you just think, wow, like how much self-control and how much calm has he brought into his system by being able to even, whatever, as sort of create some different relationship with the gas exchange and with his own response to carbon dioxide so that he can calm himself down and get into such a state of relaxation. So I think that there's many different versions of slow, deep breathing. And there's some with, halting at the top of the breath, halting at the bottom of the breath. And I think all of them really work around this idea of optimizing the relationship between these two systems of your respiration and your heart rate.
And I would second that. Whenever the first time that I hooked up myself to a good HRV monitor, I like HeartMath. They've been doing it for 20, 30 years. Real pro system there. It is absolutely amazing what happens when you start breathing in a slow rhythm. And I think you nailed it as a good rule of thumb. 6 breaths per minute, 5 breaths per minute. In between that is great for everyone. For taller people, you should breathe even slower. I learned that from Richard Brown at Columbia, who's been researching coherent breathing for 20 years, which I thought was interesting, to about 3 breaths a minute. So if you're above around 6'1", 6'2", you can breathe even slower. But in order to really find your rhythm, it is helpful to look at one of these HRV monitors. I have one, and it's also interesting to see different people of different sizes can respond differently. So 5 to 6 breaths a minute is a good general gauge, but then there's more nuances on top of that. But if you don't have one of these monitors, you can try this 5-6 breaths a minute and you can see for yourself. Right now, we've got a couple questions coming in.
Okay.
You were going to say something.
Oh, I was just going to say one thing about, we use a HeartMath in the lab. We really love, they're very much research-based, huge amount of integrity science, evidence-based. What did I want to say? Oh yeah, so I have a friend at USC, Mara Mather, and she's been using the HeartMath, having people do, I don't know how exactly, we should look up the methods, but I think it's like 30 minutes a day or 10 minutes a day over 6 weeks. And she shows increases in white matter in the frontal cortex with this slow, deep breathing approach using biofeedback. So I think that, you know, it's a super powerful system. It's free. I mean, obviously the machine costs something, but you could just do slow, deep breathing and get the same results. So I think that's something that's so important to me, is that everything I recommend in this book is free. And it's just tuning into your natural systems that are already there and that we're ignoring.
I was talking to Dr. Belisa Vranic, who is really an expert in the biomechanics of breathing, and she's a psychologist. She said you cannot really fix anxiety unless you fix breathing, which I thought was a pretty bold statement. She's like, you can blunt it, you can numb it out for a while, but you can never fix it. She said the vast majority, basically everyone with a serious chronic anxiety disorder, especially panic disorders, has a serious breathing dysfunction. Is that a coincidence? Probably not. I think Helen was just, somebody said something. Okay, there you are.
Yes, it was me, the voice of Oz.
Okay.
We have some questions. So I'm going to start off with one from Kalina, who starts off with saying, "Hi, Sarah, what an interesting talk. Thank you."
Hi, Kalina.
Her question is about development of the upstate downstate rhythm. She says babies and young children have a very different sleep-wake rhythm than adults. So I imagine that restore functions also have a different rhythm as you get older. Could you address that for us?
Oh, this is one of my favorite parts of this book, was able to tell this particular story. And it's not my story to tell. It's really, it's Julian Thayer's and his colleagues. He has a really interesting theory that's called the generalized unsafety theory of stress, GUTS. Just in case you want to look that up, it's very powerful. But you're right. The systems of sympathetic, parasympathetic, rev, restore are differently balanced when we're infants and when we're children. And the idea is that we actually, and the idea from Julian and his group, or Thayer, I should call it Dr. Thayer. I actually have a paper coming out with him, which I'm really excited about in PNAS, but if anyone wants to check it out, what their theory is that children and all animals come into this world as stressed out, rev, better safe than sorry systems with basically no restore function whatsoever, with no parasympathetic function whatsoever. And it's only with lived experience of safety is their main principle. But it's really community, love, I'm getting fed, I'm warm, people love me, I can, and that's the first signals of, that I'm safe, right? And then that builds up. You don't have to, you come into the world screaming as this infant, and suddenly you're being taken care of, and you can calm down and you can self-soothe, and somebody can help you soothe, right? And that's the building up of the restore system. And it's also the building up of your frontal cortex. And as we get older, we experience more and more opportunities to test this system out, to test out whether, it moves from child system, which is very much dependent on the world, but, has some self-soothing qualities, to then being an adolescent and then really having to test out, can I control my systems around me? Can I control the world around me? Am I safe? And can I make myself safe? And all of those experiences build up the restore system, and it's experience dependent, right? So if you are somebody who's had deprivation, scarcity in early life, you may not have had those restore systems that make you feel safe, right? You may not have had that deep connection. And so that's something that makes it harder along the way to actually feel self-regulated, feel self-control, have control of your emotions, have control over your moods and your anger, basically. So those, there's a really powerful developmental story within this that I think that could be my next book.
Well, actually, somebody asked you, Alessio said, it's very interesting. What's next for your research into the relationship between the automatic nervous system and human behavior? Sorry, the autonomic nervous system.
I mean, so the thing, so there's the book world of how to turn these things into sort of comprehensible frameworks for people to understand. And then there's my research, my lab. If you want to check out the research that we do, it's the sleepandcognitionlab.com or .org. And one of the things that we're super excited about is looking at how the heart and the brain, the autonomic and the central nervous system are interacting during sleep and during waking to support our different cognitive systems. So we, a typical study is that people do a whole bunch of different memory tests, long-term memory, working memory, emotional regulation, creativity, any kind of, cognitive or emotional tests that we're looking at. And then we have them sleep in the lab where we measure their brain activity with EEG, and we measure their autonomic activity with the ECG. But we're also having people sleep in the scanner so we can look at the functional magnetic resonance imaging scanner, so we can look at how their brain activity via this bold signal, this oxygenated blood signal, brain activity changes during sleep. And then we test them when they wake up and we see how did their performance change, and then what happened during sleeping brain activity that supported that change. So that's one of the, that's a big area in my lab. But we're also really have a whole branch of research looking at rhythms within women, because women, as we all know, have been terribly understudied throughout the history of science. And now there's more and more women scientists, so there's more and more women doing this research. So we're also, we're looking at women across the menstrual cycle, which is just another cycle, right? There's the upstate of all the hormones being high, and then there's the downstate of your menstrual cycle where you have no hormones. And what is the effect of that rhythm on sleep, cognition, mood, all these different questions. So we have a bunch of studies. And then how does that affect women when they go into menopause, right? Where those hormones start to fluctuate and then disappear. So that's another question that we're looking at.
Thank you. A question from Pamela. Thank you, Sarah. This is fabulous. Can't wait to read the book. Do the seasonal changes from and to daylight savings time cause stress to us? And now that we might not have that time change, will this improve if there is a negative?
Man, the sleep world is just losing their minds right now about these changes that are going on, where there's a movement to try to take to let go of the time change, right? It would just stop having time change. But the question is whether we should stick with this daylight savings time or the standard time. And that's a really big world that I just go with what the sleep people or the circadian rhythm. I mean, it's like, wow, just 1 hour matter. Well, for people who really know about this research, they say that 1 hour really does matter. And so for the research on increased risk of heart attack, increased car accidents, having less light during the day will probably have a big effect on our circadian rhythms. And so which one we choose is incredibly, it's a big topic right now.
Thank you. We have another question here. Actually, it's a question for both of you, and that's James. I'm going to send this one to you first. Can realigning eating and sleeping habits along with practicing breath techniques actually lower high blood pressure? And conversely, does working all night writing on a laptop lead to high blood pressure?
I will try to answer that as best as I can. Does diet and lack of exercise and how you breathe affect your blood pressure? Yes, in a huge, huge way. Can you reduce your blood pressure by adopting a healthier diet and exercising a little more and breathing in a correct way? Absolutely. So a lot of people, when they're talking about hypertension, the only thing that's prescribed beyond drugs, which do work, is dietary changes. Sometimes exercise is prescribed as well, but very rarely do people talk about breathing, and especially sleep disordered breathing, which is
not good, because you can eat the right foods and you can exercise all day. If you're breathing dysfunctionally at night, if you have apnea, you will still have hypertension. So I have seen several studies. There need to be more, but almost as importantly, I've talked to probably hundreds of people now who have changed their breathing, specifically how they're breathing at night, which is as important, if not more important, than how they're breathing in day, and have marked enormous changes in their blood pressure. Right now, I could have anyone with high blood pressure breathe for about 5 minutes, and I guarantee I could get your blood pressure down 5 to 10 points. The trick is it will just go back up when you stop breathing that way. So it's about making healthy breathing a habit, not sitting down on a couch and doing it for 5 minutes and saying, I'm done. I'm going to go back to eating, double Whoppers and breathing dysfunctionally. It's about making all this stuff, integrating it all together, making it a habit. But let's hear what the real scientist says about all this. Sara, please.
Yeah, it's we didn't actually talk about exercise, which is actually a huge part of the upstate downstate story. There's so much research that shows that exercise, eating right, and deep breathing techniques are heart healthy. Giving your heart a rest is incredibly important. It does a very hard job all day of pumping your blood against gravity all the way around your system. And this and the amount of stress that we are putting on the heart is basically just a recipe for hypertension. And so there's so much data now showing that all of these systems are interacting, right? Like a lot of the time they're just looking at one system of eating or one system of exercise or one system of breathing, but they're all showing the same research, is that when you start to actually improve on these things, you are you're decreasing your hypertension and you're decreasing your risk for cardiovascular disorders. And so much of this starts with breath, because breath is the restore response. It is calming down your revving sympathetic response, right? So they're all integrated. Exercise, one of the strong reasons exercise is so powerful is that it creates a burst of sympathetic, it revs you up at activity. And over time, your restore system is trying to calm down the rev response. And so it turns on later in the day. And when you can then time, this is one of the concepts that I think is really fun and key to the book, is that when you can time that big like HIIT workout or big cardiovascular workout to be in the morning, that autonomic restore response that happens hours later gets synchronized with your deep sleep, which is where you have your slow waves, and it expands and amplifies the restorative system. And this is also, extremely healthy for your cardiovascular system. So for sure, yes, everything you've heard from your grandmother and your great-grandmother are correct in terms of exercise, eating, and I don't know if she talked about breathing, but yes.
She should have.
She should have.
Sorry, Grandma. Yeah.
We're getting to the end now, but we do have a couple more questions to address. One from Karen, which may be wishful thinking, but maybe you can answer this. What can the government do to support our downstate?
Oh, such a good question. I have a feeling this is the Karen that's sitting with my two kids, Jesper and Violet, in another room, but I don't know if that's true, but if it is, I love this. So what can our governments do, but also what can corporations do, right? The bosses, the ones with all the money. What can we do, right? We can invest in more parks, in more recreational nature activities so that people can be in nature more often. We can incentivize exercise, good eating habits by giving financial incentives to people for their health insurance, for maybe perks at the end of the year, depending on how many steps that they've taken, right? We can incentive, we like, you know, maybe there could be like a HRV competition for who can have the biggest amount of restore function, right? There's so much we can do to incentivize healthy behaviors, and particularly in underserved populations, right? This is where the real rubber meets the road. Like, well, you know, when you're of a certain a socioeconomic status, you have money to eat well. You have money to have a gym membership. You have money to take vacations. A lot of people do not have that kind of money, and they don't have those opportunities. There's very few parks in poor neighborhoods. Those parks are not safe, right? There's very few vacation days that people are taking because they have to work multiple jobs. There are food deserts, which I know is an objectionable word, but there are food apartheids, right? Where people are living in poor neighborhoods and all they have is a dollar store to get their food from, right? We're talking about all these things that they shouldn't be privileged, but they are, because the way our governments have allowed corporations to dictate who gets what in this world. So I think that there's a really strong argument to be made that this has to happen at a very high level, because equity and opportunity is doled out at this level. It's definitely in the individual, but it's also up here.
James, how much do you think, I mean, this is a follow-on question I'm actually posing, how much difference do you think it would make if companies and offices were to introduce some kind of breath training or encouraged breathing techniques within the workplace in terms of productivity, in terms of work health?
Well, I don't think there's ever been a randomized controlled trial of two different companies doing that, but there's been thousands and thousands of other scientific studies looking at different groups of people, a control group not breathing, the group that is being studied to be breathing differently, and of course it would make a difference. It's to me, it will always be a net gain. There will always be a benefit, right? That benefit may be very small for some people or may be completely transformative for other people. You don't know until you do it. But the good thing is, as Sara mentioned, is this stuff is free. We breathe all day long. It's available to everyone, everywhere, all the time, from the moment you're born to the moment you die. And so why not try to improve those 25,000 breaths you take every day? Just taking control of it a little bit can make a huge difference. I've seen this time and time again. I get letters every single day from people saying this. So this is not some placebo effect. It's easily measurable. It's a biological effect that happens when you change your respiration.
Yeah, and I'll just add that I think it won't not benefit corporations, right? Like they are paying for health insurance, right? They are paying a lot of money for health insurance, and so if we can do things that would reduce diabetes, that reduce dementia, Alzheimer's, that reduce cardiovascular risk, this will also help corporations. So it will be a two-way street here.
Yeah. Well, we are at time. Sara and James, thank you for a very enlightening discussion this evening. I can't wait to read the book and incorporate some of your recommendations into my own life, and I'm sure everybody else feels the same. A reminder that signed copies of The Power of the Downstate are available at Oblong Books and online at oblongbooks.com. Similarly, copies of Breath by James Nestor can also be ordered. Before we close, I would like to extend our thanks to Michelle Aielli and Hachette Book Group for helping make this event happen. And congratulations again, Sara, on publication. And thank you to all of us for joining us this evening. It's been delightful, and we appreciate you spending some time out of your evening with us. Good night, everyone.
Thank you.
Night.
Bye.
Thanks, James.